Welcome. Building small form factor PCs is a constant battle to fit the most powerful components into the smallest cases. For ITX builds to achieve silent operation with an RTX 4090, we previously used external cooling. But then is it really ITX? This upgraded build with a delidded Intel i9-14900KS and a Strix 4090 can operate as a completely standalone ITX build. Or simply connect the Mora 3 for uncompromised performance while also remaining cool and quiet. Let's build it right here, right now, and then we'll test it. This is the Vector Network, and let's begin. But before that, Frozen CPU is the official sponsor of the Vector Network. Follow the links in the description to get the parts in this video from Frozen CPU with same-day shipping, cashback for upgrades with the rewards program, and at the lowest price guaranteed. The Lian Li Q58 is a 14.5-liter ITX case with a dual-chamber layout similar to that of the Fractal Terra, which was used in the previous external Radiator build. This case is taller, allowing for extra cooling options that makes this build possible. For the CPU, we'll use Intel's flagship i9-14900KS. This special edition processor can consume over 300 watts of power while boosting its cores up to 6.2 GHz. The best way to cool this chip is by first delidding the integrated heat spreader IHS and then cooling directly the CPU die with liquid metal. This 14900KS was delidded by the Iceman Cooler CPU delid tool. Follow the link in the description for a step-by-step delidding video. With the CPU delidded, we'll use the Iceman Cooler direct die water block, allowing for enhanced heat dissipation, then a water block on top of the heat spreader, enabling full performance for the CPU. For the GPU, we'll use the ROG Strix RTX 4090 with an Optimus signature water block. Besides the unique look, this combo was tested on the channel and found to have top-tier thermals and performance. While the 1/8-pin CPU power connector on ITX motherboards is more power limited than having two connectors, the ROG Strix Z690i with its 10+1 phase VRM setup is perfectly capable of operating the i9-14900KS. It's time to start the build. Starting with the CPU, we'll be applying liquid metal as a higher quality thermal interface between our delidded 14900KS and the Iceman Cooler direct die water block. But first, it's important to ensure the protection of the SMD components from the conductive liquid metal. Nail polish works, and once dried, creates a protective and durable layer on these parts. For thermal material, we're using Thermal Grizzly Conductinaut, which is a liquid metal with a much higher thermal conductivity than traditional thermal paste. The thinnest layer is to be applied directly to the die and also on the cold plate on the back of the water block. Now it's time to remove the stock independent loading mechanism, ILM, while keeping the back plate in place. Let's drop the 14900KS into the motherboard. Then the Iceman Cooler direct die water block goes right on top, followed by the 4 screws previously securing the ILM in a crisscross pattern to apply pressure more evenly. Now let's grab our fittings. These are 16x10 compression fittings from Optimus and will work with the 16x10 soft tubing we're using for the build. The fittings have a clean look and we're using black to complement the rest of the components. We'll also use EK Quantum 45° and 90° adapters, a micro 90° adapter, 14mm extension fittings, and a drain valve. We'll also use Koolance QD3 quick disconnect female fittings with 16x10 compression fittings and with standard G1/4" threads, and QD3 male fittings also with 16x10 compression fittings and with standard threads. For completely optional and cleaner look, Optimus 16x10 compression fitting covers can be used instead of the Koolance covers. From here, we'll drop in 2 EK Quantum 14mm extenders and 2 90° torque adapters with a pair of Optimus 16x10 compression fittings. We're using 32GB of Corsair Vengeance DDR5 memory in a 2-stick kit at the speed of 6400 megatransfers. This is the fastest low-profile 32GB kit supported to run XMP. For storage, we have two M.2 NVMe slots so we'll populate them both with two 4TB drives for a total of 8TB of storage with Gen 4 speeds. Let's prepare the Lian Li Q58 case by removing the front, top, and side panels and the bracket for the radiator. Remove the hot swap SSD tray for space. Remove the fan and LED hub for radiator clearance. Remove the riser cable bracket for GPU clearance. Temporarily remove the underneath bracket and the power supply bracket. Now we can drop in the fully loaded ITX motherboard and secure it with 4 motherboard screws. And then insert the riser cable. The Optimus Signature GPU block is unique in appearance, and paired with the ROG Strix RTX 4090 OC, the combination offers potentially the best performance and cooling on the market. On the back, we'll use a pair of water-cooled plugs, which are noticeably slimmer than the Optimus plugs, to ensure that the GPU will sit flush in the vertical mount. Let's drop in a pair of EK Quantum 90-degree adapters and 2 Optimus 16x10 compression fittings. For the case pump, we are using a Xylem DDC pump. This compact pump will be used when the external radiator with a D5 pump is disconnected. For the pump top and case mounting, we're using the Aqua Computer Ulti-Top DDC pump cover with anti-vibration mounts. Slide in the pump mounts into the Ulti-Top DDC pump cover. Drop in the DDC pump and secure the pieces together with 4 hex screws. Let's add a pair of EK Quantum Micro 90-degree adapters and a pair of Optimus 16x10 compression fittings to the DDC pump cover. Then secure the fully loaded DDC pump to the case with 2 hex screws and metal washers. We're using the Corsair SF1000L, a 1000 watt small form factor power supply, which comes with a 600 watt 12 volt high power cable and micro connectors for the PSU. The micro connectors are significantly smaller than their regular counterparts and are exceptionally convenient. Now let's secure the PSU bracket onto the power supply with 4 PSU screws. Then mount the PSU bracket into the case with 5 case screws. Temporarily remove the power adapter for GPU clearance. Now we can insert the fully loaded RTX 4090 into the PCIe 4.0 riser cable and secure it to the case with 2 Phillips head thumb screws. And also put back and secure the power adapter. We'll use the water-cooled heat killer PCI pass-through slot that allows for tube runs to pass through from the inside to the outside of the case, and vice versa. For installation, we need to assemble the pass-through slot around the case bracket. Once in place, we can secure the pieces together with 3 hex screws. And to the case with a thumb screw. Let's drop in a pair of EK Quantum 45-degree adapters and Koolance QD3 quick disconnect female fittings. On the inside, we'll add Koolance male and female QD3s with standard G1/4" threads. This is a good time to plug in the 12 volt high power cable and also the power adapter plug, and also power switch, the front panel USB Type A cable, USB Type C cable, and front panel audio. For the option to standalone cool this ITX build without connecting an external radiator, we're using the water-cooled heat killer 280S radiator inside the case. To cool the radiator, we're using a pair of Noctua NF-A14 Chromax Black 140mm fans for its high performance and low noise profile. Let's place the 2 fans on the radiator in a pole configuration, exhausting air from the case. Then secure the case bracket to the radiator with 8 radiator screws. Drop in 2 pairs of EK Quantum Torque 90-degree adapters and Optimus 16x10 compression fittings. Then we can drop the fully loaded bracket into the case and secure it with 4 case screws. For tubing, we're using water-cooled heat killer EPDM 16mm outer diameter, 10mm inner diameter soft tubing. For soft tubing, this matte black EPDM is the greatest of all time. Let's start the tube runs by connecting a Koolance female QD3 compression fitting, attaching it to the inlet of the GPU block, connecting it to the outlet of the PCI pass-through slot, then the outlet of the GPU block, to the inlet of the DDC pump, then the inlet of the radiator, to the outlet of the DDC pump. For tube clearance, this is a good time to plug in the CPU 8-pin power cable, then the outlet of the radiator to the inlet of the CPU water block, then connecting a Koolance male QD3 compression fitting, attaching it to the outlet of the CPU water block, connecting it to the inlet of the PCI pass-through slot. We'll then plug in the 24-pin power cable for the motherboard and the Molex peripheral power cable. We'll use the Aqua Computer Quadro to control the custom loop for the components in the case. Let's mount it to the underneath case bracket with the 2 hex screws and metal washers. Then we can slide and secure the underneath bracket into place. Let's connect the Molex power cable, Noctua fans, the DDC pump, and the motherboard USB cable. Then connect the DDC pump to Molex power. This is potentially the highest performing GPU and CPU combo currently available, built with flagship performing parts in a sub 15-liter case. Next, we're building the external radiator to provide completely silent operation and further unleash the system's power. The build begins with the water-cooled Mora 3 420 for Noctua NFA20. The Mora stands for Monster Radiator, for maximum performance with the highest build quality. The radiator fins here are more spaced out, designed to allow for high cooling performance even at low RPM speeds. There are 4 spots, each for the Noctua NFA20 200mm fans for quiet operation and outstanding heat dissipation. For the pump, we're using the Aqua Computer D5 Next. This is a D5 pump with a detachable controller unit that houses an OLED display and 3 integrated buttons for input and operation. This D5 pump enables the Aqua Suite software, connects via SATA power, provides coolant temperature, and has an integrated 25-watt fan header. To build the reservoir pump combo, we're using the water-cooled heat killer D5 pump bottom and 100mm blue anodized aluminum struts. Let's start by attaching 4 metal struts to the bottom with 4 hex screws. For the Aqua Computer Next D5 pump, let's first remove the controller unit. Then we can drop in the black rubber O-ring, followed by the D5 pump and the pump bracket, and secured by 8 hex screws. Then we can put back the controller unit. For mounting, we're using the water-cooled heat killer basic mount. First, unscrew the 4 hex screws to loosen the strut grips, and hand screw in the 4 anti-vibration screws. Then we can slide a pair of basic mounts onto 2 of the metal struts. Next, we're using the water-cooled heat killer multi-port top with plexiglass downpipe and the water-cooled heat killer 100mm glass tube. Let's screw in the inlet downpipe and drop in the clear rubber O-ring followed by the glass tube. And drop in another clear rubber O-ring, then place the multi-port top and the glass tube together and secure the top to the metal struts with 4 hex screws. We're using the water-cooled Mora 3 adapter to attach the reservoir pump combo to the Mora. Let's secure the Mora 3 adapter to the unit with the 4 hex screws and metal washers. Now we can tighten the mount grips on both sides, then drop in an EK Quantum 90-degree torque adapter and a pair of Optimus 16x10 compression fittings. Then we can secure the unit to the Mora with another 4 hex screws and metal washers. To cool the Mora 3, we have the 4 Noctua NF820 fans. These 200mm fans are 30mm thick and have a maximum RPM of 800. These fans are designed to produce high performance while even running at silent RPM levels. The fans are 30mm thick, so 35mm radiator screws are used. Let's start by securing one fan with 4 radiator screws. We'll use the Mora X splitter designed to simplify the wiring in combination with the Mora 3 420 and the Noctua NF820 fans. Let's connect the X splitter to the attached NF820 and then connect 2 more fans with 8 radiator screws. Then attach an extension 4-pin fan cable to the X splitter and secure the 4th fan with 4 radiator screws. We're using the water-cooled Mora 3 420 fan grill classic and high, allowing for fans with maximum 38mm height. To make way for the grill, there are 4 Phillips head screws to remove, 1 in each corner. Now let's place the grill on top and secure it with the 4 high grill screws. Next, let's install an Optimus 16x10 compression fitting to the top of the reservoir. Then connect the outlet on the Mora 3 to the inlet of the reservoir with the downpipe. We'll connect a pair of Koolance QD3 male 16x10 compression fittings. Attach one to the outlet on the reservoir. Install an EK Quantum 90-degree adapter and an Optimus 16x10 compression fitting to the bottom side of the Mora 3. Attach the other QD3 male fitting to the inlet on the Mora 3. And also an EK Quantum 45-degree adapter and drain port. The adapter allows for full 360-degree movement for convenience. Now let's plug in the cable for the 4 fans on the Mora and the SATA power cable. We'll use an adapter to power the pump's SATA cable, which is then plugged into an outlet with a switch. The Mora 3 is larger than a typical radiator, so we'll use 5 liters of distilled water with Primo Chilled Liquid Utopia as biocide for longer term maintenance. Put a jumper on the motherboard 24-pin cable, fill the reservoir, and then flip the switch for the D5 pump. Even with the Mora 3 connected, the DDC pump is turned on and set to a low and silent RPM level. Now to convert the build to operate without the external radiator. Turning off the pumps, we can disconnect the Mora from the case. Disconnecting the pass-through slot inlet and outlet runs, and then connecting them together to allow the flow of water to run in a closed loop. Now we can leak test just the ITX build. With the leak test over, the build is finally complete. So how does it run? Let's test it to find out. For testing, we'll start with the build in ITX standalone mode with ambient room temperature at 21 degrees Celsius. To obtain the results, the 140mm fans were set to 100% speed and the DDC pump to 50% speed. In 3D Mark Speedway, the GPU core and memory temperatures were 51 and 66 degrees Celsius respectively. Then undervolting the card to 0.95 millivolts and adding 200 megahertz to the core clock, the GPU core and memory temperatures decreased 4 degrees Celsius each to 47 and 62 degrees Celsius, respectively. The GPU power usage decreased approximately 15% or 80 watts. For comparison, we'll test the build in the Mora Max Performance mode. The 140mm fans and the DDC pump were both set to 20% speed. In 3D Mark Speedway, the GPU core and memory temperatures decreased 8 degrees Celsius each to 43 and 58 degrees Celsius, respectively. Turning down the fan and pump speeds to 40%, in Speedway, the GPU core and memory temperatures decreased 5 degrees Celsius each to 46 and 61 degrees Celsius, respectively. The main difference is that with the Mora at 40% speed, the build is silent. It's noiseless. By connecting the external radiator, we can turn down the pump and fans to allow for silent operation while still keeping the components incredibly cool. And while it is large, the Mora can go right under a desk for maximum space saving. For the CPU, we're using the Intel Extreme BIOS profile. In Cinebench multi-core, the CPU core temperature averaged 72 degrees Celsius while pulling 320 watts of power. This remained largely unchanged in any of the modes. The results are satisfying after the delidding and liquid metal application. For gaming in standalone mode, we'll switch to the Intel Performance BIOS profile for the CPU and undervolt the GPU. In Cyberpunk 2077 Overdrive mode with path tracing, DLSS quality, ray reconstruction, and frame generation on, the CPU core, GPU core, and memory temperatures averaged 45, 42, and 52 degrees Celsius, respectively. The CPU and GPU combined for 400 watts and averaged 82 FPS. So there we have it. This build has the best of everything: cutting-edge parts, silent external cooling, and compact portability. There are two options for use: a maximum performance setup with an external radiator, or a super portable configuration for gaming and less intensive loads. Like the video by clicking the like button. If this is your first time here, go ahead and subscribe to the channel. This is the Vector Network. Thank you, and I'll see you at the next episode.